Hi friends, welcome to my channel. Let's have a look at today's daily challenge problem. Problem 2244. Minimum rounds to complete all tasks. In this video, we're going to explain a solution based on some elementary math. First, I'll read through the problem statement to digest the requirements, and then we do the analysis and explain the code. First, the statement. We are given a zero-indexed integer array called tasks, and where tasks I represents the difficulty level of a task. In each round, we can complete either 2 or 3 tasks of the same difficulty level. We are required to return the minimum rounds required to complete all the tasks. Otherwise, -1 if it's impossible to complete all the tasks. So here are 2 examples. So in example 2, so we can finish the tasks with difficulty level 3. However, there's only 1 task with difficulty level 2, so we cannot finish. So we return -1. And in the first example, so there are 2 3s and 3 2s, so we can use 2 rounds to finish these tasks with levels 2 and 3. So there are say 5 4s, so we can use 2 rounds. 1 round we finish 3 of the 5 tasks, and the other round we finish 2 of them, the remaining 2. So another 2 rounds. So in total there are 4 rounds. So before we do the analysis, let's also look at the constraints. First, the length of the tasks array or list is bounded in between 1 and 10 to the power 5. Secondly, so each task or the difficulty levels for this is in between 1 and 10 to the power 9. So let's just see it's positive. So with that said, we are ready to do the analysis. So here the treatment is based on some elementary math. So the idea and the procedure actually is very intuitive or very natural. First, we need to finish tasks with the same difficulty level. So this is very easy to observe. And secondly, for each difficulty level, we need to check if we can finish the tasks with that level. And if so, what's the minimum rounds to finish all such tasks? Third, if we couldn't finish the tasks corresponding to a difficulty level, then we cannot finish all the tasks, so we return -1. Otherwise, we do summation of the minimal rounds for all possible difficulty levels, right? So this is our overall idea. So here, assume for a difficulty level, so there are n tasks, right? And then the second part above is nothing but to check if we could decompose n as a linear combination of 2 and 3, right? In other words, if we can write n equals 2k times 3m, where k and m are non-negative integers or integer coefficients. So to use minimal rounds, we use as many 3s as possible, right? If there's 2 remains, so we just use 2. So this is our overall procedure and our overall getting principle. So next, let's do the coding. So in order to explain the code in a modularized way, so first I'm going to write a hyperfunction. So this hyperfunction will check for certain difficulty level if we have n tasks of that level, if we can finish those tasks, and what's the minimal rounds needed. So let's call this decompose, right? So let's consider this n to be a positive number, right? So let me add some annotations or document. So here n, let's assume it's a positive integer, right? In the context of this problem. So here the purpose of this function is to check if n can be written as n equals 2k times plus 3cm, something like this. Anyway, so where k and m are non-negative coefficients, integer coefficients. If this is the case, so we return the minimum rounds needed. Otherwise, I'll return -1, right? In other words, we cannot finish. So this is the purpose of this hyperfunction. So this is actually just some integer division with remainder, right? So here, let me first do this. QR as div mode. So I'm going to check n divided by 3, right? The reason we divided by 3 is to make the total number of rounds minimal, right? So there are 3 possibilities depending on the value of r, either 0 or 1 or 2, right? If r equals 0, right, then we actually just need q round. So each round we finish 3 tasks. So we return q. This is the one case. Another case, if r equals 1, right? So in this case, so we consider 2 cases. If q equals 0, so we just have one task with a certain difficulty level, so we cannot finish. So we return -1. And otherwise, as q will be greater than, so here q is 1. If q is 0, so if q is greater than 0, in other words, greater than or equal to 1, so we can pick one of the q, or in other words, one of the 3, match the remaining r, that is 4 tasks. We use 2 rounds. Each round we finish 2. So we are going to return q minus 1 plus 2, right? So in other words, so this is q plus 1. So here, let me comment that. So here, q minus 1 is that we use 1, 3 plus 1. Then we use 2 rounds. Each round we finish 2, right? So this is the case. And another case is r equals 2. This is an easy case, actually. We use q plus 1, right? Q is for corresponding to each time, each round we finish 3 tasks. This one corresponds to the round we finish 2 tasks, right? So that's the hyperfunction, right? With that said, we are ready to do the check, right? Then prepare the return. So for this, first I'm going to get the frequencies of the unique difficulty levels, right? So the collections, we can directly use this, use a counter, right? So then we are going to put tasks here, and then we are going to set the result to be 0, right? And then we check if we can finish all the tasks corresponding to the different difficulty levels, right? So for n in count values, right, we are only care about the frequencies, right? Then temp will be decomposed of this frequency, right? If the return is -1, so we just return -1, done. And otherwise, so we are going to increment the round, that is temp, right? And finally, we are going to return result. This result will be representing the total number of rounds. If in between the for loop, nothing or -1 is not returned. So that's about it for this specific daily challenge problem. I guess for now, let's first do a check. Yeah, it passes the first example. So now let's look at the generic case. Yeah, it passes all the cases. So overall, this problem is marked as medium by Leetcode. So actually, if you follow the analysis, so the logic here is actually rather straightforward. So essentially, what we used is nothing but some elementary math or decomposition, right? Writes this frequencies into linear combinations of 2s and 3s, and then use get the number of rounds greedily. So with that said, I guess that's about it for this video. Thank you.